Hello everyone, welcome to this tutorial on finding the minimal set of functional dependency in a database. Today we will learn what minimal FDs are, why they matter and how to derive them step by step. Here's what we are covering today. A quick introduction to functional dependency, what they are and how they work. They will explore then we will be exploring what makes a set of functional dependency minimal, followed by the three-step process to simplify them. We will also walk through an example and wrap it up with a takeaways and a Q&A question. To begin with, the functional dependencies play a big role in designing and normalizing databases. Understanding how to derive a minimal set helps simplifying the schema and reduce redundancy and ensure better data integrity. Now move on to the next slide. We have what are the functional dependency. In database management system, our functional dependency, often abbreviated as FD. It is a constraint that expresses how a relationship between two set of attributes are defined. If a attribute set X determines Y, we write it as X to Y. This means for any value of X, the value of Y is uniquely determined. They are essential for ensuring consistency and designing better databases. Now we go to next slide. What is minimal set of functional dependency? A minimal set of functional dependency is a simpler equivalent version of a larger set. To qualify as a minimal, let me go on to the point by point. To have a minimal, every FD should have only one attribute on the right hand side. No necessary attribute should be there on the left hand side, and no dependency should be abundant. Using a minimal FD helps in achieving more proper normalization and clear schema design. To step by step decompose the right hand side, first of all, let's dive into the step 1 of decomposing the right hand side. We will make sure that each FD has one attribute on the right. So if we see something like A to B C, we break it down into A to B and A to C. This makes FD easier to analyze and manageable. Next step is by cleaning up the left hand side. We test if each attribute in the determinant is really necessary. If an attribute can be removed without affecting the outcome, it is considered as extragenous. For example, AB to C. If B alone determines the C, then A is unnecessary and should be removed. Next step, by eliminating the redundant functional dependency. In step 3, we look for the functional dependency that can be derived from other FDs in the set. If we can infer a dependency using the rest of the set, it is redundant and should be eliminated. This step helps in achieve the reach minimal form without losing any meaningful relationship. Now get to an example. Let's walk through an example. We are giving three FDs. First one is AB to C, A to B and B to C. In step 1, they already have a single attribute on the right hand side, so we are good. Next step 2, check if AB to C has an extragenous attribute. Since B to C exists, is unnecessary. Step 3, AB to C, AB and B to C together amplify A to C, so AB to C is also redundant. That leaves us a minimal set, A to B and B to C double dash. Now comes final minimal set of a functional dependency. So after simplification, our minimal set is A to B and B to C. This version is easier to maintain and ensures clarity and avoid unnecessary complexity in the database schema. Now move on to the conclusion part. In the summary, to derive a minimal set of functional dependency, we need to decompose a multi-attribute right hand sides. Next step is to remove the extraneous attribute from the left. And third step, to eliminate any redundant dependency. Doing this is essential for proper database normalization and cleaner design. Thank you for all watching. I hope this tutorial clarified the steps to find minimal functional dependency. If you have any question, I feel free to ask, and don't forget to like, share and subscribe for more tutorials on the DBMS and database design.